All right, let's look at u substitution with definite integrals. When you do u substitution with definite integrals, it's the same as before with the indefinite ones. The only difference is at the end, you've got two options. You can either um, put the answer back in terms of x and plug in the original endpoints, or when you do the actual substitution part, you can translate your endpoints from x values to u values. And that's what I tend to do. Both are fine, but I'm going to translate my endpoints probably pretty much all the time. So let's look at this example. Um, on this one, I'm going to let my u be this. So let's see, u is going to be x squared minus 1. du is going to be 2x dx. And 1/2 du is going to be x dx. All right. Now also, I've got to translate my endpoints. But before we do that, let's rewrite the integral. So I've got 3 x squared minus 1 squared x dx. I realize I didn't change anything there other than some ordering, and I want to mention why. Because on here, I've got the 3. Then this gets replaced with u squared. And then the x dx gets replaced with 1/2 du. And notice I don't have any endpoints on those. What I need to do is translate my endpoints. On the top, what I'm going to do is take the 1 and I'm going to plug it into here. So for my top endpoint, u is going to be 1 squared minus 1. So that's 0. And for the bottom, I'm going to take my bottom endpoint 0 and plug it into here to get my u. So the bottom, I get u equals 0 squared minus 1, which is negative 1. So over here, this goes from negative 1 to 0. Now, I guess on that 1 in the middle, I should leave that as 0 to 1 because that's still an integral that has x for its variable. Typically, if you have a few steps in the middle where maybe you've got a mix of x's and u's, it's fine with me if you just leave the endpoints off during that part of it. So what we've done here is we've just translated it into this integral over here. So let's see, can we do that? Well, we've got 3 halves. U squared gives me 1/3 u cubed. And we're going from 0 to negative 1. Again, just let me say that. The 3 and the half come together to give you this. U squared gives you u cubed over 3. Now we've got to plug in our endpoints. So the 3's cancel, and we're left with 1/2 u cubed from 0 to negative 1. So that's 1/2 times negative 1 cubed minus 1/2 times 0 cubed. So this is just minus 1/2. All right. Let's do the next one. All right, on this one, my u is going to be 4 minus x squared. du is going to be minus 2x dx. And I guess maybe I should go ahead and make x dx, since x dx shows up in the problem. X dx is going to be du divided by negative 2. All right, for the top, my endpoint is going to be 4 minus 2 squared, which is 0. And on the bottom, I get 4 minus negative 2 squared, which is also 0. So notice what this turns into. The 3 stays. This becomes u. dx, the x and the dx together get replaced with minus du over 2. And I don't want to just write it in like that. It looks like subtraction. I need to put it in parentheses there. So let's see, I've got minus 3/2 u du. But notice my endpoints are both 0. So I don't even have to do the integration step. With both of the endpoints being 0, I know that the answer is going to be 0. And let's see, let's look at this one on my Riemann sum calculator just to see it. If we come over here and look at it, this is 3x times 4 minus x squared. Let me standardize my zoom. For some reason this isn't doing it. Try that again. 3x times 4 minus x squared. It doesn't like the fact that it wants a... There we go. So this is what we've got. And we're going from, what is it, -2 to 2? So by symmetry, if we put in a bunch of rectangles here and look at it, by symmetry you can see that the area above the axis cancels out the area below. So it makes good sense that this is 0. I guess I should also mention, we didn't really need u substitution for this one, because that 4 minus x squared, it's not raised to any power or anything. I could have just distributed that 3x across there. So this is not the best example in the world, but it works just fine. All right, let's see. Let's do this. Let's do one more example in this video. On this thing, we've got 2x plus 1 to the third power. That 2x squared plus 1, that's going to be my inside function. So my du is going to be 4x dx. And let's see, how do I want to deal with this? This is 8x dx. I'm going to rewrite that as 2 times 4x dx. Now keep in mind, if you've got a dx at the end like this, it's perfectly fine to move it up top on the fraction. So I'm going to rewrite it like that. That way I can rewrite my integral up top. I've got the 2 stays, then the 4x dx gets replaced with du, and underneath that becomes u cubed. All right, so what about my endpoints? On the top, I get u equals 2x squared plus 1. Again, I'm just taking this and plugging it into here to get the u value. So 2 times 1 squared plus 1, that gives me 3. And for the bottom, u is 2 times 0 squared plus 1, so that's 1. So this is all my substitution stuff. My new endpoints are going to be 1 to 3. All right, how do I integrate this? Probably what I would do is rewrite it as 1 to 3 of 2u to the minus 3 du. So I integrate that out, I'm going to get 2u to the minus 2 divided by -2 from 1 to 3. So that's minus, let's see, the 2's cancel away. I get minus 1 over u squared from 1 to 3. Let me just double check that. The 2's cancel away. We've still got the negative. The u goes downstairs and becomes u squared. All right, so plug in my endpoints. I get minus 1 over 3 squared minus minus 1 over 1 squared. So that's minus a ninth, and then plus 1 gives me 8 over 9. And that's it. Let's see, this next example, let's see, we've got several more examples, so I'm going to cut this video off here and we'll pick up with the rest of them in the next video.